Combined Science topic, Ionic bonding.
So we want to start about ionic bonding. Though in chemistry we have three types of bonding. We have what we call ionic bonding, we have covalent bonding and metallic bonding. But in combined science, we are only required to do two types of bonding. That is ionic bonding and covalent bonding. So for now, what is bonding? To bond is to join. So chemical bonding, it is when atoms with the different elements, they combine together. For example, as we said earlier, that we have got several types of atoms on the periodic table. If we can combine carbon and oxygen, they can do a certain type of a bonding. So in what is ionic bonding? Ionic bonding, it is when atoms gain and lose electrons. It is the reaction between metals and non-metals, which means that there's a reaction of positively charged atoms and negatively charged atoms. So metals have positive ions, they are called cations. Then non-metals have negative ions, they are called anions. So the electrons that are involved in all types of bonding, either covalent or either ionic bonding or whatsoever, they are called valence electrons. They are called valence electrons. That's their name, valence electrons. So in this diagram or in this example, we want to practice or want to show an example of bonding. Bonding in sodium. Bonding in sodium chloride. Bonding in sodium chloride. So what are the statements? What are the statements? Sodium has one electron in its outer shell. If you can practice electron configuration of sodium, for example, if one can say do an electron configuration of sodium, we can show by this. In the first shell, sodium has got 11 protons, which is the proton number of sodium is 11. In the first shell, you can place 2 electrons. Second shell, you can place 8 electrons as required by electron configuration. Then the third shell has got 1 electron. Are we together? Then chlorine, how many atoms does it have? It has got 7, not atoms. How many protons does it have? Chlorine have got 17. So in the first shell, we put 2 electrons. Second shell, we use 8 again, because the proton number of chlorine is 17. Then 2 plus 12 plus this one, 10, 11, 12, 13, 14, 15, 16, then we say 17 here. So the reason why we have considered chlorine to be a positive atom as shown on the diagram, the reason why we do it is because elements on the periodic table, that is elements in group 1 and group 2, they are post-transitional metals. It's sometimes sodium can be considered as a non-metal or as a metal at the same time, but chlorine in this case can be considered as a metal. Are we together? So when doing ionic bonding of these elements, we are saying sodium has 1 electron in its outer shell. According to the rules and regulations of electron configuration, the rule states that the first shell can contain up to 2 electrons. Second shell can contain up to 8 electrons. Then the third shell can contain up to 1 electron. Are we together? Then in this case, the problem here is sodium has this 1 electron which is disturbing the third shell. And in this case, to chlorine, 7 electrons are disturbing again this outer shell, this third shell. Because instead of this shell having 7 electrons, it must have how many electrons? 8. So for them to share, for them to gain valence, they started to share or they started to bond. So how did they bond? A chlorine atom has got 17 electrons. It attains a noble gas configuration. For both of these atoms to attain a noble gas configuration, sodium needs to lose this 1 electron to chlorine, and chlorine needs to gain this one electron in order to attain a noble gas configuration. So our equal sign is represented with this arrow. Then we open brackets. Then sodium is now being displayed as like this. First shell got 2 electrons. Then second shell we have got 8 electrons. Then we say it gained valence of 1. Why? Because we are saying that this shell was disturbing the noble gas configuration of sodium. So if sodium loses this 1 electron, we say it gains valence plus 1. Are we together? Then again, chlorine, in this case, it has got positively charged electrons. In the first shell, put 2 electrons. In the second shell, we also put 8 electrons. Then in the third shell, we are no longer using these 7 negative charge electrons, positive charge electrons only. We are now displaying it like this. Third shell, 2 here, 2 here, 2 here, then a positive here and a negative. Then we say it's -1. Why? If we say 17 plus -1, the answer is -16. So this negative electron is affected all these elements, so they are now being considered negative. So in our scientific approach, it is written NaCl like this one. Others who want can say -1, but we can leave it like this. It is considered as a correct answer. Any question?